Hey everyone, and welcome back to the AI Research Roundup. I'm your host, Alex. Today is May 3rd, 2025, and we're looking at an interesting piece from ICLR published just over 3 months ago on January 22nd, titled Consistency Checks for Language Model Forecasters. Alright, this ICLR conference paper tackles the challenge of evaluating LLM forecasters, especially for long-term predictions, proposing a new way based on checking logical consistency instead of waiting for ground truth. So, the authors visualize this relationship in Figure 1. These scatter plots compare their consistency metrics, the frequentist metric on scraped data and the arbitrage metric on news API data, against the actual ground truth accuracy, which is the average Breyer score. Lower scores are better on both axes, and you can see a positive correlation. Models with fewer consistency violations tend to perform better on the ground truth, supporting this evaluation method. Okay, building on that visualization, Table 1 here gives us the specific numbers for those correlations. It breaks down the correlation between the consistency metrics, arbitrage and frequentist, and the Breyer score for each of the 10 logical checks, across both the scraped and news API datasets. We see some checks correlate much more strongly than others, especially COND and COND, showing high values like 0.92, strongly suggesting they're good proxies for actual forecasting accuracy. Alright, and Figure 2 really highlights those strong correlations we saw in the table for COND and COND. You see plot A. That's the COND arbitrage metric versus Breyer score on scraped data, a super tight 0.92 correlation. Then plot B shows the COND frequentist metric on news API data, again, a clear positive trend. These visuals really emphasize how well these specific conditional probability checks predict the actual accuracy of the models. Continuing from those plots, this table from page 16 actually defines the 10 logical checks used throughout the study. For each check, like negation or the highly correlated COND and COND, it lists the related questions, or tuple, and the mathematical condition that the probabilities assigned by a perfectly consistent forecaster should meet. It's the formal basis for the consistency metrics we've been discussing, showing exactly what's being measured. Okay, so after defining the logical checks, this figure, from page 17, describes the actual data structure for the forecasting questions themselves. You see fields like a unique ID, the question text, resolution criteria, the expected resolution date, and importantly, the question type, which is binary or conditional binary here, plus its source and eventual resolution. This standardized format is crucial. It's what allows their automated pipeline to handle and evaluate all these diverse questions consistently. Right, and to make this more concrete, this figure gives us an actual example of one of those question tuples, specifically for the AND logical check. You see 3 related questions here. P asks about a US AI law, Q about a Canadian AI policy, both before January 1st, 2028. Then P underscore and underscore Q asks if both will happen. This illustrates how the system groups questions together to apply those logical consistency conditions we saw earlier. So seeing that concrete example helps tie it all together. Alright, to wrap up then, the main point is that these consistency metrics, especially those conditional probability checks like COND and COND, they can serve as valuable, quick indicators of LLM forecasting accuracy, which is super useful when ground truth is years away. But simply enforcing consistency doesn't guarantee better forecasting overall. That's our roundup for today. Thanks for listening. I'm Alex.